Hello everyone, in this video tutorial, we will implement face emotion recognition and the IDE which I will be using is Expense. Expense is an efficient and affordable platform where you can build, deploy, monitor and share your machine learning, deep learning and computer vision models. And the aim of Expense is to make AI accessible for all. The video tutorial is divided into three parts. In the first part, we will look into the dataset. In the second part, we will train our convolutional neural network model using face emotion recognition dataset. In the third part, we will deploy our trained model inside Expense and will test it on images as well. So let's get started. So here is the dataset which I will be using in this project. So let's look at the dataset description. The dataset consists of 48 cross 48 pixel grayscale images of faces. The faces has been automatically registered so that the face is more or less considered or less centered and occupies about the same amount of space in each image. Okay, and here you can see that we are detecting around 7 different types of facial expression, which is angry, disgust, fear, happy, sad, surprise, and neutral. So these are 7 different types of face expression or emotions which we are detecting over here. So here we have the train.csv file, test.csv file, ISML face data.csv file, and the example submission.csv file. Okay. So the train.csv file contains two columns, emotion and pixel. The emotion column contains a numeric code ranging from 0 to 6, like I have shown you over here. 0 refers to angry and 6 refers to neutral, and around from 0 to 6 we have 1 representing disgust and 2 representing fear and so on. So the emotion column contains a numeric code ranging from 0 to 6 inclusive for the emotion that represent in the image. So what the emotion is being represented in the image, we have the emotion column which contains the which refers to that emotion. Like if the person is sad in the image, so then in the emotion column, we have the number 4, which is representing that the person is sad in the image. Then we have the second column, which is pixels column. The pixel columns contain a string surrounded in quotes for each image. The content of this string, a space separated pixel value in row major order. So here we have the pixel column, which contains the string in quotes for each image. So in the pixel column, we basically have the strings we have the string quotes, surrounded quotes for each of the image. Okay. So then we have the test.csv. The test.csv columns contain only pixel column. So in the test.csv file, we don't have the emotion column. We only have the pixel column, and we basically want our task is basically to predict the emotion columns. Okay. So in train.csv, we have two columns, emotion and pixel. While in text.csv file, we have only one column, which is pixel column, and our task is to predict the emotion column. So in the training set, we have around 28,709 examples, and the public test set used for the ladder board consists of 3,589 examples. Okay. So what basically in the data description, what we can see is basically we have two columns, emotion and pixels. Emotion columns contains the emotions with respect to each pixel, with respect to each image. For example, if the person is sad in the image, then the emotion will be sad. If the person is angry in the image, then we have the emotion as angry, which is represented by a numeric value of 0. And for here, we don't have the images. We have the pixel column. So, and the pixel columns contain the strings surrounded in code for each of the image. So here we don't have the images. We have the pixel column, and the pixel columns contain a string surrounded in quotes for each of the image. Okay. So if you just want to go through more details, you can just go it. And for this project, I will be using this dataset file, ICML face data.csv. So as we go on towards the code, we will discuss more in detail. Okay, so we will be using this CSV file in this project. So as I told you in the start, for this project or for this tutorial, we are using expense.com, expense IDE. So I have already explained about the expense IDE at the start. So let's go towards the coding part. So first, in the first step, just open the web browser and just write expense.com and just open this. Okay, so I have already logged in, but if you haven't created your account, you just need to create your account in the first step over here. Okay, so I have already created my account, so I will just sign in with Google. But if you haven't created your account, you need to just create your account in the first step. Okay, so I'm just signing in with Google. Okay, so now here you can see that you will see the balance. So my balance is $9.26 left. But if you just create your account for the first time, you will be given $25 free credit. So what are you waiting for? Just go to expense.com and just create your free account and get $25 free credits at the start. Okay, which you can use to for your any project. You can just train your model on GPU, Tesla T4, Tesla V100 GPUs. Okay, so and if you just want to buy the premium membership, you can just go for here and see more details from here. You can just click over here and just click on upgrade account if you just want to buy the pro membership or elite membership. It's your choice. Currently, I'm using the forever free basic plan, so it offers $25 one time $25. So you can just get it if you just create your account for the first time. You will be given $25 free credit. Okay. So as you create your account over here, you will be given $25 free credit, which you can use when to train any of your model, to deploy or to deploy your Flask API and so on. So first of all, we will just click on create project over here and just write the name. Here you can see that three different projects. I was just practicing before different techniques, different methods. So I just created multiple projects over here. And so first of all, I will just click on create project and just write face emotion. So just write the project name over here, face emotion recognition tutorial. Okay. So just write it over here and click on create project. If you just want to add the description, you can also add it and then click on here and then click on Jupyter Notebook and then just click on create new notebook. So this will create a new notebook, but in front of your screen, as you can see over here. Okay. So you can see that we have Tesla T4, Tesla V100. We have the default CPU available over here. We have the Tesla T4 GPU and Tesla V100 GPU available here as well. So I will just select Tesla T4 GPU for this tutorial. You can also select Tesla V100 GPU as well. Basically, Tesla V100 GPU is better than Tesla T4 GPU. It offers more RAM. Tesla V100 GPU offers more RAM than Tesla T4 GPU. Okay. So I will just like default container image from here. And basically I am using TensorFlow in this project. So I will just like expense TensorFlow. But if you are working on PyTorch, you can just like PyTorch. Or if you're just using TensorFlow, like I'm just using TensorFlow in this project. So I will select expense TensorFlow. And then I will just click on open file. So this will create a new notebook over here. This might take few seconds, so please bear with me until it gets all ready. In the project file section, you can see different project files, different data set, which I have already uploaded in my previous projects while working on my previous projects. And you can see here, it offers 5 GB, up to 5 GB free space. But if you buy the Elite membership, you will be given 100 GB till 100 GB space over here. Okay, so here you can just I now have created a new project and you can just simply start by importing all the required libraries like import pandas, SPD, and import numpy as NP. But if I just start doing code from very scratch, it will take quite some time. So I have already prepared a notebook script for this tutorial. So I will just open this notebook script by clicking on open, or just go over here and click on upload files. And I will just upload this file from here to here. Now you can see here, the file is uploaded. This is the notebook file which I have prepared for this tutorial, and I will just click over this and click on open file. So this notebook file will be opened over here, and then we will discuss the code in detail. So in the first step, I will just import the required libraries. In the first step, I'm just importing the SYS library, sys library. Then I'm just importing the OS library. OS library help us to navigate between different file paths. And then I'm just importing the pandas library. Pandas library is used for analyzing, cleaning, and exploring and manipulating data. Then I'm just importing the NumPy library. A NumPy library is used for working with arrays, but here we will be using NumPy library to convert an list into array. So here we will be using NumPy library to convert a list into an array. Then for the visualization, I will be using matplotlib library to visualize my data. Then I'm just importing sequential from TensorFlow.Keras.models. So basically, sequential and functional are two ways to build Keras models. Sequential model is simplest type of model in which is basically a linear stack of layers. Okay, so there are two ways to build Keras models, which you can I have written over this here as well. One is a sequential and other is the functional way. So sequential method is the most simplest method, which is just a linear stack of layers. While so in sequential, you can simply stack you can only stack one layer after another. While in functional model, you can connect. So in functional model, I can connect a layer to literally any other layer. Like I can connect the first layer to the last dense layer by skipping the layers in the middle. But in a sequential, you just need to go step by step. Okay, you cannot connect the first layer to any other layer, but so you can just stack one layer after another in sequential. So I'm just using sequential model here to build my Keras model. And then from TensorFlow.Keras.layers, I'm importing convolution 2D. So a convolution 2D layer basically applies sliding convolution filters to 2D input. The layer convolves the input by moving the filters along the input horizontally as well as vertically. So it basically computes the dot products of the weights and the input. Okay, so then we have the dense layer. So with the final layer in the CNN is the fully connected or dense layer. So the final layer in the convolution neural network is basically fully connected, or you can say the dense layer. So in Keras, we just use dense to create these layers. Like you can see that I will be using dense to create a fully connected layer, or you can say that output layer in the last of my convolution neural network. So in basically Keras, a fully connected layer is referred as a dense layer. Okay, so then we have the max pooling 2D. There are two types of pooling operations. Basically, one is max pooling and other is average pooling. And here we are just using max pooling 2D operation. So each pooling layer in a CNN is basically created using max pooling 2D class that simply performs the max pooling operation in two-dimensional space. Okay. Then we have the batch normalization. So batch normalization is a normalization technique done between the layers of a neural network instead in the raw data. It is done along mini batches instead of fully data set. Is served as to it. So basically, batch normalization is used to speed up the training and use higher learning rates and make learning very much easier. Okay, just correct it. Then we have the dropout layer. So dropout layer basically reduces the complexity of a neural network and prevents it from overfitting. Then we have the flatten layer. Flatten layer is used to make the multiple dimensional input one dimensional. So before the dense layer, we have the flatten layer. Okay, so after convolution 2D layers, we have the flatten layer. So after convolution 2D layers, we have the flatten layer. So flatten layer is basically used to make the multi-dimensional input one dimension. So it is commonly used in transition process from convolution layer to fully connected layer. Like I've showed you, in the fully connected layer, we have the dense layer. So to do the transition from fully connected layer to that from to the transition from convolution layer to the fully connected layer, in between that we have the this flatten layer. Okay, so flatten layer is used when we want to do the transition from the convolution layer to the fully connected layer. So in between them we have the flatten layer. Flatten layer is used to make the multiple dimension input one dimensional, and it is used when we are doing transition from the convolution layer to the fully connected layer. Then we have the loss as categorical cross entropy. So we have the binary cross entropy loss as well, but here we will be using categorical cost entropy. So categorical cost entropy loss is used where in the case of multiple class classification. So as you can see there, we have 7 different classes. So we will be using categorical cost entropy. But if we have if we have the case like 0, 1 or such class, we have only either we have to find that if there is a dog in the image or not, then we can simply use the binary cost entropy. But here we have the multiple class, so we will be using categorical cross entropy loss for multiple class classification model. Then here we are just importing the Adam optimizer. Then here we have importing np-utils to convert the class vector into binary class matrix. So using np-utils, we are just converting a class vectors integers to binary class matrix. Like if we have two numeric number, like if we have 2, to convert this into binary class, we have the output in the form of 1, 0. If we have 5, to convert into binary class, we have the output 1, 0, 1. And similarly, if we have 6, we have the output 0, 1, 1. Okay, so this is all like we convert a class vector integer, which is like 2, into binary class matrix using np-utils. So I have just placed this data set over here. I have just placed this .csv file into my Google Drive. icml-face-data.csv file is being placed into my Google Drive. So I will just download this file from Drive directly into the Google Colab notebook. So I've just passed the path over here. So now this file will be downloaded from this CSV file will be downloaded from my Drive into this expense notebook. So I am just missing Google Colab. It's not the expense notebook. So to download these files from the so I will just download this CSV file, this icml-face-data.csv file from so I just placed this file onto my drive. So I will just download this file from the drive into my expense notebook over here. Okay. So just run this. So this will download the file from the drive into the expense notebook. Meanwhile, just run these cells as well. So when we just reach towards the training, so we have run it. So that's why I'm just running all these cells. Okay. So now you can see over here, here we can see that CSV file FER 2013.csv. FER stands for face emotion recognition. And this is basically dataset what belongs to 2013. So just written 2013 over here, and this is a .csv file. So we have the .csv file format over here as well. So let's just read the dataset into our expense notebook. So we will be using pandas library to read the dataset inside the expense notebook. And let me just show you the first few rows of the dataset. So here we have the emotion like 0. These are basically the indexes. And here we have the emotion column. 0 represents angry, and then we have around from 0 to 6. Like we have 7. We are detecting 7 different emotions inside the images. And here we have the pixels column, and here we have the usage column, which refers like whether this image belongs to a training set or the testing set or private test set or not. Okay, so usage column basically refers that whether the following image belongs to a training set or the test set. And here we have the shape of the data set. We have 3 columns: emotion, pixel, usage column, and we have around 35,887 rows in our data set. And just checking the unique values inside the emotion column. So we have 6 different types of, we have 7 different types of emotions, or we are detecting 7 different types of emotions over here. And for the training, we have 28,709 images. For the testing, public testing, we have 3,589 images. And for the private test, we have the 3,589 images as well. So I'm just pre-processing the data set and just appending the values into my list over here. So I just created 4 empty list over here, and I will be just appending these values into this empty list, which you can see over here. Okay, so I'm just processing the data, and where we have the training we have in the usage column where we have the training, we are just training value. We are just appending those pixel values into our training set, and where we have the public test value in the usage column. Like you can see here, just not showing over here, but in the usage column, we have the public test variable as well. So when we will have the public test in the usage column, we are just appending those values in the xtest list over here. Okay, so after just appending those values into this list using NumPy, uh, as we have imported NumPy, so using NumPy, we are just converting this list into an array. Okay, using just converting this list into a NumPy array over here. So here we have the training. Train.y file contains the emotion, and x-train contains the pixels, and the train.y contains the emotion values. And similarly, x-text contains the pixel, and test-y contains the emotion values. So using np-utils.to-categoricals, I'm just converting this integers value, which you can see over here, into a binary format. Like you can see over here, currently I have not converted this integers value into binary class format. So after, if I just run this cell over here, let me just run all these previous cells which I have not run. I should run these cells meanwhile, so anything not skipped. Okay, so just running these cells, just give me a minute. So now, before I just apply two-dot categorical operation, you can see over here, we have around integers values in the emotion. Okay, so now just converting this integers value into binary class format using np-utils.to-categorical to convert this integer value into binary class format. Okay, so now you can see here we have number of classes as 7. So now you can see we have converted the integer values into binary class format, which you can see over here. So that's perfectly looking fine over here. So let's go ahead and do this for the test y-y. So the test y basically contain our emotions values. So just converting this test y from the integers into the binary class format, just like we did for the train y. So now I will be just normalizing my data into the between 0 and 1. So like you can see here, I'm just normalizing my pixel values between 0 and 1. Currently, my pixel values are not between 0 and 1. You can see over here, my pixel value is 70, 80. So I'm just normalizing these pixel values between 0 and 1. Okay, using mean and standard deviation, I'm just normalizing the pixel values between 0 and 1. So now you can see that after applying mean and standard deviation, my pixel values are being normalized between 0 and 1. Over here, you can see. So that's look cool. Similarly, we will do for the X test, which contains test data for the pixel values. In the X test, we have the pixel values. So now just apply the mean and standard deviation to just normalize the values between 0 and 1. Okay. So now if we see the shape of our training data set, it's around 2304. Okay. So, and this is the number of images, number of samples we have in our training data, and this is the number of samples we have in our testing data, and this is the shape. But as we just want to train our convolutional neural network model on this data, so this data should be converted into a valid format for the training. So now I'm just reshaping the data. So if you just multiply 48 cross 48, so now you can see that it comes appear as 2304. So if you just multiply 48 cross 48, it will appear as 2304. And while we are just reshaping our values into this 48 dot comma 48 format, and why we have the 1, because we have the images in the form of, or our images in the dataset was in the form of grayscale. So here we have that 1, or if your dataset images are in the form of RGB, or so we will have here 3. But here our dataset images are in the grayscale form, so we have 1. But if the images in the dataset are in the RGB format, then we will have 3. And if I just show you again over here, go back towards it. So now you can see here the data consists of 48 cross 48 pixels grayscale images of face. So we have 48 cross 48 pixel grayscale images of face. So I'm just reshaping my data set into 48 cross 48 over here. Okay, so after reshaping the data, just check this shape of the data. So now similarly, I will check the shape of my test data after reshaping the test data set. Okay, So now here you can see that I have defined a convolutional neural network. So our the, convolutional neural network model consists of three convolution layers, and we have fully connected dense layer over here as well, which you can see over here. So we have three fully convolution 2D layers, or three convolution layers, and what we have one fully connected layer as well, in which we have the dense layer. So we have applied max pooling 2D, dropout. I have already explained you about convolution 2D, max pooling 2D, and dropout. And here we have the activation function as softmax. So where we just we use the software maximum function when we have multiple classes, but if we have one to class, then we use the sigmoid activation function. And here we have the activation function at ReLU. So uh, ReLU this activation function is used when we just want to skip the negative values. And here we have a stride as 2 cross 2, and here we have also set the pool size as 2 comma 2 as well. Okay, so just run this cell and let's create a convolution neural network for our this project. Okay, so now you can see that here we have the model summary over here. So you can see over here. Okay, so I've just started the training. I've just run multiple cells. So the training is started. Okay, so now you can see here, we are just using the loss as categorical cross entropy. Okay, I think I've just not compiled it. So just run this cell again. So now just run this cell again. I hope it will work fine. Okay. So it's about to start now. Okay, so now you can see that the training has started. We are training our model, convolutional neural network, non-neural network model on 200 epochs. And you can see over here. So the training might take some time. Okay, so I'm just pausing the video, and as the training completes, I will be back and show you the accuracy and loss plot for the training and validation as well. Plus, we will save our model weights into the JSON format as well as in the H5 format. So we will use them when we create the Flask API as well. So the training has started. We have set the batch size as 64. We are training the convolutional neural not network model on 200 epochs. We have the validation data defined over here. We have set the shuffle is equal to true so that our data gets shuffled. Okay, and we are just using a categorical cross entropy loss because we have multiple classes and we have set the metrics or the evaluation metrics as accuracy. So the training is pursuing, so it's around 11 epochs. Model has convolutional neural network model has trained on 11 epochs, but it will take some time to complete a training on 200 epochs, and on each epoch, on each epoch, the average training duration is 8 seconds. So let's wait for the training to complete. And as the training completes, I will be back and then we will discuss the training results in detail. So finally, we have trained the convolutional neural network on face emotion recognition dataset for 200 epochs. And we can see that at the end of, after completing 200 epochs, we are able to get a training accuracy of 90%, while a validation accuracy of 56.67% is being achieved, while the training loss is 30.13% and or 0.3013, sorry, it is 0.3013, and the validation loss is 1.9251. So let's save our model weights into the JSON format as well as in the .h5 format. So I'm just saving the model weights into the JSON format as well as in the H5 format as well. And let's plot the training and accuracy loss plots. And for that validation, I'm just plotting the accuracy for the training and validation, as well as I'm just plotting the training loss and the validation loss as well. So now you can see that after some time, like you can see here, after 25 epochs, the validation accuracy almost remains constant, like it is around 0.55 to 57 or 55 to 57%, while the training accuracy continuously increases and it reaches to 90%. So what analysis I can draw is if we just train our convolutional neural network model on 300 epochs, the training accuracy will further increase, but the validation accuracy will around remain constant, like you can see over here. But with the loss, we can see that the training loss in the blue line is continuously decreasing, while the validation loss is a bit increasing. Like the validation loss goes down in the start, but then it increase, and after some time it becomes like around constant, while the training accuracy is exponentially increasing, and that's good. So I've just saved the model weights. So now you can see here, we can see the model, my model weights are saved by model complete.json and model complete.h5. So I'm just download the weights from here. Just click on download file and just download the weights file from here in the JSON and H5 format. And in the next step part, we will see how we can create a Flask API and deploy the Flask API in Expense. Now we will see how we can create a Flask API and deploy it inside Expense. So after creating a Flask API and deploying it in Expense, we will test that Flask API on images as well. So let's first go, let me show you the Flask API code over here. So I will just click over here and let me just upload this app.py file, which contains the Flask API code. So let me just explain you that code first, and then we can go ahead and deploy that Flask API as well. Okay, so is it uploaded? So let me just click over here again, app, and just open this over here. So here I have the app.py file. Let me just open this file in code editor, open in code editor. So here you can see that we have the complete Flask code over here. So first of all, we are just importing the required libraries over here. And as we have trained our convolutional neural network model using CNN, so we are just importing CNN. Then we have the pillow library, plus we are just importing the NumPy library to convert the list into an array. And then we are just importing the OS library to navigate between different file paths and to to convert our output into a JSON format. We are just importing model from JSON. And okay, so that's basically we are just creating a Flask API. So just we are importing Flask over here. And so now you can see over here, I've just created a URL by dash. So if so here you can see that using app.root method, I have just created a URL and I have just set the method as post. So you can set the method at get as well, but I just recommend you to set the method as post. And in here you can see that I've just created a function by the name process. So in the first step, it requests to upload an image file. So when the user upload an image file, then it resizes the image into our required shape, because our dataset consists of all the images of 48 cross 48, and we have trained the convolutional neural network model on 48 cross 48 images. So we expect the input image to be of size 48 cross 48, and then in the next step we convert the image into an array. And then we just expand the dimensions of the image using np.expand dimensions, and then we are just dividing the image by 255.0. And then as you noted, after training the convolutional neural network model, we have just saved the model weights into the JSON format as well as in the .h5 format. So I'm just loading my model weights which are in the JSON format. You can see over here, as well as the model weights which are in the .h5 format. So I'm just uploading both the weights file, model weights file which are in the JSON format, as well as the model weights file which are in the .h5 format. And then I'm doing the predictions on that sample image which the user or I have uploaded. Okay, and after I have the model predictions, you can see here, you can just remove this line as well. Okay, so these are just duplicates. Okay, so and then I'm just doing the predictions on the sample image. Okay, so after so the predicted value will be in the form of 0, 1, 2, 3, 4, because you can have, you know, that our integer, our emotions column contains the emotion in the form of 0, 1, 2, 3, 4, 5, 6, 7. And 0 represent the angry, 2 represent the sad, and so on. 3 represent the disgust. So in this way, we have the output in the form of integers. And for example, if my output is like 0, from here I've just get the maximum index value as 0. So it means that the emotion of the person in the image is angry. If I get the max index value as 1, it means that the emotion of the person in the image is disgusting. And then if I just get the maximum index value as 2, then it means the emotion, the person in the image is feeling fear. And if I get the maximum index value as 4, it means if I get the maximum index value as 3, then it means that because I'm just counting 0, 1, 2, 3. So it means that the image is happy. And if I get the maximum index value as 4, then it means that the person in the image is sad. And if I just get the maximum index value in the image as 5, then it means that the person in the image is surprised. And if I just get the maximum index value in the image as 6, then it means that the person emotions are neutral. Okay. So after here, I will just get the predictions with respect to the maximum index. It can be angry, disgust, as per the emotions of the person in the image. And then I will just convert that prediction string into an array. And then I will just reformat this into the form of list. And then I will just convert that output into a JSON format and just print that output into our Postman or any other IDE which we will use to test that API. Okay, and then I'm just running this on port number 80. You can just change that port as well. Okay, so that's impressive. So now here I've just explained the code of the Flask API, which you can see over here. Plus further, I just want to show you a few things as well. So now you can see here, this is the app which contains the Flask API code, which I have explained you. And if I just go to the share file, here we have the our trained convolutional neural network models weights saved in the H5 format as well as the JSON format. So our trained convolutional neural network model weights are saved into the JSON format as well as in the H5 format, which you can see over here as well. Okay, so I've just placed those files over here. So let me just convert this shared files into the zip format. So I will just right click over here and then click on send to and then click on compressed zipped format. Okay, so I have already told you the share file contains my model weights the H5 format as well as the JSON format. So I'm just converting that file into compressed zip file. So the file name can be any, like this can be uh, face emotion or motion recognition. So this file can be, you can just write any name for this folder. Okay, sorry, this subfolder. So you can just set any name for this folder, and this app basically the Flask API code, which I have explained inside the expense. Okay, the code is written inside the expense. So let's just get back to the expense. Okay, now basically I will just want to upload this Flask API code and just upload the weights file as well, and just want to deploy this Flask API. Okay, so I will just go towards the deployment section. Okay, so now you can see that they are just doing practice. I've just created these 3 APIs. So let me just delete those APIs so that we have everything clearly new. So just go to view and just remove deployment. So if this is another approach, if you want to just remove your deployments, you can do this as well. Okay, so just remove those deployments. So now I've just removed all the previous deployed APIs, and then I will just click on create. And from here, I will just select the project and just reply API deployment name as emotion recognition. You can just set, it's your choice. You can set as any name, emotion recognition, and then click on create. So now you can see over here, we have created an API by the name emotion recognition, and this was the name of the project which I just created at the start, like face emotion recognition tutorial. And here is the date and the time on which I have just created this API. Okay, then it's currently status as draft because I have not deployed that API, and then I will just click on view. Okay, then I will just go to setup. So basically here, as you can see that I have just set the port number as 80, and inside the Flask API code, I have just set the port number 80 as well. But this is the default. If you just want to change this port number to 30, 20, 10, you can just set here, like you can change it to 10. But please remember this, you just need to update that in your Flask API code as well. But as the Flask API code in the app.py, I have just set the port number as 80. So I will keep that number over here. And then here we just set all the required libraries which we just want are just required to run our Flask API script. So here I just write the name of all the required libraries that are required to run the Flask API script. So if you just see over here example, you can see that as we're just running the Flask API, so the Flask library is must. So we'll just write Flask over here. Then as we have trained our convolutional neural network model using TensorFlow, so we just require TensorFlow library as well. And then we have the pillow library, because we just want to display any input image. We use pillow library. Plus, further on, if you just go over here, we have the NumPy library to convert the list into array. We just use the NumPy library. Just remember, or any other library, or just open the app.py file so you can get a better idea. Okay, so let me just navigate my screen. Okay, so here you can see that we have the app.py file. Okay, so now you can see over here, we have imported the pillow library, we have imported the NumPy library, we have imported or just written the TensorFlow library. Okay, so if there is any library left, I'm just seeing that. Okay, I don't think there is any API left, library left which we have not imported. As we have imported all the required libraries, so just get back towards the expense. Okay, so just right here, sklearn as well. So now here you can see that we have listed all the required libraries that are required to run the flask.py script. Okay, so now here I will just upload my .py file. Here the download example is also presented. So if you just click on download example, it will just download an sample Flask API code. You can take this help as well. But I will just upload here my Flask API, which I've just shown you in the code written inside expense. So this is the app.py file, which contains my Flask API code. And here I will just upload my model weights file, which are in the JSON format as well as which are in the .h5 format as well. So I will just click on choose file and just upload this share file. Okay. So I've just let me just again show you inside the share file. If I just like on all files, we have the H5 format and the JSON format files as well. So I've just converted that share file folder into a zip format, which you can see over here, and just uploaded that over here. And okay, so I think that's not uploaded. Just click on here. So now we have uploaded the Flask API code, share file.zip file, and I have listed all the required libraries that are required to run this Flask script successfully. Okay, and then I will just click on save from here. Okay, so this might take few seconds because it's saying please wait. Okay, so successfully saved. Then I will just go to over here in the deploy tab over here. So now you can see here, currently we are using default CPU API, set the port number as 80. I have just listed all the required libraries inside the pip requirements.txt file. So inside the requirements.txt file, I have listed all the required libraries, and we can see the required libraries over here as well. Flask, TensorFlow, Pillow, NumPy, sklearn. These are all the required libraries that I have listed in the setup section over here. Okay, and here app.py is a script file which contains my Flask API code, and here we have the shared file.zip which contains the model weights in the H5 as well as in the JSON format. Then you just need to click on deploy and deploy your Flask API. So the deployment is about to start. So this might take around 3 to 4 minutes to deploy it because install all the required libraries, and it takes some time, like 3 to 4 minutes. So let me just wait until it is ready to deploy. So, okay, so now you can see that the deployment is going on. So that's really impressive. Okay, so now you can see that all the required libraries are being downloaded, like Flask, TensorFlow. In a similar way, it will download the sklearn Pillow library as well. So this might take few minutes. So let me just wait until it gets completed. I will be back and explain you the rest. Okay. So will take some time. Okay. Guys, now you can see that the deployment is done, and you can see the message over here, container deployed, and our Flask API is ready. So that's great. And if I just go to API details, I can see the URL over here. So I will just click on copy from here. Okay. So now I'm just open Postman from here to test my API on some sample image. Okay, so I'm just opening the Postman from here. Okay, so you can just download this Postman app from online. So it's available and it's free to download as well. Okay, so let me just navigate my screen towards this Postman now. Okay, so now here after opening the Postman, I will just go to new from here and click on HTTP request from here. Okay, and from here, I will just select the method as post, because when I was creating a Flask API, I told you that I have selected the method or written the method on my Flask API file, app.py file as post. So if your choice, you can just choose the get or post method both, but I have just chosen the post method. So I will just choose the post method from here, and here I will just paste my API, which I have just copied from the expense, and I will just go to body from here, and then I will just click on form data. Okay, and from here I will just select instead of text, I will just select file from here, and from here I will just upload a sample file. I will just go to face emotion recognition. Okay, just go to over here and just I hope I have some sample image saved over here. Okay, I will let me just check out. Let me just use this save image from here. Okay, and just write the name of the file as image over here, and just click on send from here and see what output do we get. So now you can see that I have just uploaded an image, and I'm just getting the emotion recognition as neutral. So that's great. So what we have done here is that we have just copied this API from here, like you can see over here. Now I've just copied this API from here. Okay, and just pasted this API in Postman, and here I've just uploaded a sample image and just named that image as image. And here you can see that I am able to detect the emotion. So let me just show you this as saved image, what this image is as well. So let me just open this. Okay, just give me a minute. So if I just navigate my screen, so now you can see here, this is Elon Musk photo, and you can see that his reactions are about neutral. So we are detecting that this is reactions are neutral. As his reactions are neutral, so we are just detecting that a neutral face over here, because we are detecting face emotion, and here we can have detected a neutral face over here. So that's all from this video tutorial. In this video tutorial, we have learned how we can choose like an appropriate data set for our project. We have chosen the face emotion recognition dataset from Kaggle. Then we trained our convolutional neural network model on this face emotion recognition dataset. And then we basically created an Flask API for our to deploy our trained model. And then after creating the Flask API, we just do the deployment within Expanse, and then we just test our API Postman and see that whether we are able to detect the face emotion or not. So that's all from this video tutorial. I hope you have learned something from this video tutorial. See you all in the next video. Till then, bye bye.